What is up, chemistry? Welcome back to the dirt bike shed. We finally got some dirt biking done, and now the weekend is over, and you and I are going to discuss solubility of solutes in solvents. So we're going to be learning some new scientific terms, and this is all very, very straightforward stuff. So here we go. All right, check it out. Got a little beaker. Put some water in there. Not a bunch. Slap about 100 milliliters of water in there. You could probably look down there and read the level over the screen. All right. Got 100 milliliters of water. So now we've measured them amount. Now water is what we call a solvent. Water is a solvent. It is a substance in which something can be dissolved into. Okay. Now solvents don't have to be liquids. But when you think about the word solvent, I want you to think about water, because we call it the universal solvent. Now, here's an example of a powder that we might put in water. This is sodium phosphate. You should know the formula for that. Sodium phosphate. And sodium phosphate is a solute. So we can take this solute and we can put it into the solvent, right? And we could dissolve it in there, right? Okay, so there's solute and solvent. What are some other solutes that you use around the house? Well, there are two we've discussed in class. We've mentioned them many times. The two solutes that you use in your home are salt and sugar, right? Those are the two solutes. I'm going to take some ice. I'm going to put some ice in this water. And of course, some of the ice is going to melt. And that's going to give us a little over 100 milliliters of water. So try to forgive me for that. But I'm going to try to make some cold water. Now I'm going to throw this little magnet in there and we'll start mixing. Now the mixing is just going to help the ice melt at this point. So let's let it mix. All right, we're mixing it. We've got the temperature going down. I'm going to read the temperature right here to you. It might be hard for you to read, but I am reading that the temperature in there is about 10 degrees Celsius. And you can see I put about 50 milliliters of ice in there because the volume is up at 150. So we go. So got some very, very cold water. That'd be chilly. I'm down to 8, 7. When it gets down to 5, we're going to do a little trick here. All right, you can hear the mixer going in the background. We're trying to get that water down to about 5 degrees Celsius. I'm going to get some sugar here. Let's get us some sugar. Let's pour some sugar on this. I'm going to get 15 grams of sugar. Now, 15 grams of sugar would dissolve very, very easily in 150 milliliters of warm water. But our water is pretty chilly over here, so we're going to see what happens. All right, you can see the temperature is about 8 degrees Celsius. And I've got a little over 150 milliliters of water in there. You can see the little stir down in there. Here comes 15 grams of sugar. All right. I don't know about you, but I can still see the sugar sitting on the bottom of the jar. There's a bunch of sugar in there. I thought I just told you that sugar dissolved very easily in water. Well, there are several things going wrong here. What are some things that you know from cooking? Some ways that you can get sugar to dissolve. Well, if you're from the South, you may like sweet tea. If you've ever made sweet tea, or if you've ever even made Kool-Aid, you know one thing. Something you can physically do to the water is stir it. Now, stirring helps, right? So we're stirring this water. It's cold water. We've got 15 grams of sugar and about 150 milliliters of water at below 10 degrees Celsius. And if you notice, the sugar is not wanting to dissolve. There are a lot of grains in there moving around. We should use some warm water. Why would we want to use warm water? Let's think about energy. why would we want to use warm water? Well, the very simple answer is warm water has more energy. And you would say, Mr. Perkins, the energy here is that magnet spinning. What are you talking about? Well, we know that energy is temperature. In other words, temperature is a measure of the kinetic energy of the molecules in a substance, okay? Now, cold water, the molecules are vibrating more slowly than in hot water. And if you have molecules of water, they're invisible, okay? But if they're moving quicker, they're going to be having collisions with the sugar molecules, and it's going to make the sugar dissolve faster. Tell you what though, this water right here, it looks like I've dissolved all the sugar. I don't see any grains left. I don't see any grains left in it. Nope, there are grains in there. It did not dissolve. So we haven't dissolved this yet. An example you may already be thinking of is if you go to a restaurant and you order sweet tea, and they bring you cold tea that is unsweetened and hand you a sugar packet, you can't dissolve the sugar because the tea is already cold. So you just end up with unsweetened tea with a bunch of sugar in the bottom of your glass. All right? Now, if I didn't have time to warm up this water, what's one little trick I could do to get the sugar to dissolve? Okay? I've already tried stirring it. I'm not going to shake it because there's not a lid on here. What's a little something I could do? Well, an obvious thing I could do is just add some more water. Boom. Now, I've added more water. Therefore, there's more room for the sugar to dissolve. And even if the water is the exact same temperature, there's more water there. So, the same amount of sugar in more water is what we would call diluted. Diluted water or diluted sweet tea would not taste very sweet. Now, what is the opposite of diluted? Just make a guess. The opposite of diluted is concentrated. The opposite of diluted is concentrated. When you make really sweet Kool-Aid or you make really sweet tasting sweet tea, it's concentrated. So I added some more water, and now all the sugar's dissolved because there was more water in which the sugar could dissolve. Does that make sense? It makes sense to me. Now, one thing I know is that I could put more sugar in here. I could put more sugar in here and get it to dissolve. This water is what we call unsaturated with sugar. Unsaturated means it's capable of holding more sugar. Let me show you. I have 10 more grams of sugar I'm going to put in here. Whoops. There's 10 more grams of sugar. I'm going to start stirring, and I'm going to give it a minute. We'll turn off the camera while it stirs, but we're going to be able to dissolve all the sugar. Still dissolving. We're still working on it. You can see grains of sugar here still, right? All right, so we've dissolved the sugar. I don't think we can put much more sugar in here. And there's a certain point where this water, this amount of water at this temperature, there's a certain point where it will dissolve the sugar, but you can't put any more in it. If you put more in it, then it won't dissolve. Now that point is called the saturation point. And when we talk about the saturation point of a solvent, we have to talk about the volume and the temperature. So, for example, 50 grams of sugar could dissolve in 150 milliliters of water at 20 degrees Celsius. That would be describing the saturation point. Okay. If I put more sugar in past that point, you will just have grains of sugar on the bottom, and the water will not taste any sweeter. There is a way, however, to trick saturated water into holding more sugar. And you may be thinking, oh, Mr. Perkins, you're just going to stir it forever. No, it's not stirring. It's not shaking. What else can we manipulate about this water besides the volume and besides stirring it? How could I give this water more energy to dissolve the sugar? You're right. We could make it hotter. Now, this is an age-old trick. We can stir the water. We can also, boop, turn on the heat. Now, when we turn on the heat, this thing gets hot super fast, okay? So we're warming up the water. I'm going to let it get warm for a second, and you're going to see the temperature go up on the thermometer. Let me give us a little better angle on the thermometer. The temperature on the thermometer is already climbing. I'm going to take a break till it gets warmer. All right, it's getting warmer now. Now we've got this water to 33 degrees Celsius. So that's warm. That's warm. We're up around 90 degrees Fahrenheit. So that is some nice warm water. That'd be a little sauna. Now that I've warmed the water up, I can put a lot more sugar in if I'm trying to make some sweet, sweet tea. Here comes 15 more grams of sugar. Look at all that sugar. Now that the water's warmer, it's going to be no problem to dissolve the sugar. We can make a nice sweet Kool-Aid drink, and if you watch how quickly it's happening. Again, why does warm water do a better job? Because it has more what? It has more kinetic energy. And that kinetic energy, the molecules moving around, they're colliding more often with the sugar molecules, right? So having more kinetic energy creates more collisions. So you can see that we've already dissolved 15 more grams of sugar in that water, and the truth is we could put a lot more. It's still not saturated. But we're going to do a trick now. We're going to take a bunch of ice and we're going to pour it back in here, and we're going to take the temperature down. The mixing is going to help the ice melt. Dumping this ice in is going to take the temperature back down. Now the temperature is going to go down. When we make this water cold again, it will not get rid of the sugar. The sugar will stay in the water, and that's what's important. We've tricked the water into holding more sugar than it would at that temperature. We had some water. We couldn't put any more sugar in it. We made it hotter. Then we put sugar in it. Then we cooled the water back off. That's the oldest cooking trick in the book. And that is called supersaturating. Supersaturating something. So this water is now supersaturated. Now, believe it or not, there are people whose job it is to discover the saturation or the solubility of different solvents, different solutes in solvents. Now, this is water, and these are some very typical solutes that we have in the chemistry lab. You can see there's potassium chlorate, potassium chloride, sodium chloride, potassium chromate, potassium nitrate, lead 2 nitrate, calcium chloride, and sodium nitrate. And if you look, these lines show you the amount of grams that can fit in 100 grams of water at this temperature. So this line shows you this is the saturation point at different temperatures. The volume of the water is not changing, just the temperature. So temperature is very important. Now I've got a little piece of sticky tape here, and we're going to discuss sodium chloride. See, this is table salt. Now table salt, you can see its solubility is not affected greatly by temperature. What if I had, see, this is all in 100 grams of water. What if I had 100 grams of water and I put that much table salt in it at 90 degrees Celsius? So here I am. I've put about 30, or let's say that's 29 grams of table salt at 90 degrees. We're below this line. So that water, you could put more salt in it. How much more salt? You could put 10 more grams of salt in it before you reach this point. When you're on the line, that is the saturation point of the solute. So if you had 100 grams of water at 90 degrees Celsius, you could put almost exactly 40 grams of sodium chloride in it, and it would be saturated. What if I had this much? I mean, that's crazy, but what if I had that much salt? Well, now I'm over the line. If I had that much salt in the water at this temperature, when I shouldn't be able to have more than this much on this blue line, then that's supersaturated. I wonder how I got that much salt in the water. Well, I would have had to have heated it up really, really hot and then dumped in 80 grams of salt, waited for it to dissolve, and then cool the water back off to 90 degrees. Does that make sense? So this is supersaturated. When you're on the line, you're saturated. When you're under the line, you're unsaturated. Okay? Saturated, supersaturated, unsaturated. That's pretty straightforward. Peace out from the Dirt Bike Shed, and we'll have a little worksheet to go with this tomorrow. It'll be a video worksheet.